This is from the book, a star called the Sun. I'm probably going to go over this book a lot, come to think of it. And Kelvin and Helmholtz. Kelvin was from England and von Helmholtz was German. They considered the Sun as a giant gaseous sphere slowly contracting under the forces of its own gravity. Their idea was that the gravitational energy liberated in the process that was turned into heat, keeping the Sun hot and luminous. The total amount of gravitational energy which could be liberated during the past history of the Sun is given by this formula. You have your gravitational constant. Mind you, it isn't the same gravitational constant that's used for other calculations, but for this, that's what G stands for. It's the calories per gram per second of energy loss, or of how much heat is being produced in its interior. And you have your mass, and you have your radius. So you just plug it in. You have, this is how much heat is being produced. This is how much it weighs. It's a lot of grams. 10 to the 66 grams. Of course, he forgot to put the units on there. I think that's grams. And I also believe this is centimeters because it's a radius. And when you calculate that, it comes out to be 4 times 10 to the 48 ergs. I think that's how you pronounce it. Which is a mechanical unit of energy, a erg, E-R-G. And then you take the ergs and you place them on top of this equation and you calculate how many calories that would be. You have to transfer the mechanical units of energy to heat energy. So what you do is you take however many ergs would be inside of, or how many calories would be inside of an erg, or how many ergs inside of a calorie, depending on whichever you're going to do, and you place that on the bottom to come out with 10 to the 41 calories. Obviously, the calorie is a lot more energy than an erg. So what that means, what I did there, is I took the mechanical motion of the entire volume of the Sun. This is the Sun. And it contracts mechanically. And however much mechanical contraction will take place will determine how much heat will be dissipated. So that's all I did right there, is I took the mechanical and I transformed it into heat energy. So that translates to the heat dissipation. So as this thing collapses the entire volume, it radiates heat. And then once I find how much heat energy can be released, I plug in the rate of the energy liberation on the exterior. Mind you, this was the interior, this is the exterior, and you can find out how long the Sun will shine for. And of course, it's an incredibly rough estimate of 30 million years. Now, the main point of this is Kelvin, Lord Kelvin, a very intelligent fellow, and von Helmholtz, another very intelligent fellow. They came up with this to try to explain how the Sun could remain stable for so long. But as we see here, there was a huge discrepancy, a huge bit of assumptions that were already in place that disallowed this from ever being accepted. And these assumptions, number one, the first assumption I actually wrote down on the bottom, was that scientists had assumed Earth formed from remains of the Sun's formation. So you had your star forming in the center, and then the little bits and pieces that didn't clump in the center of the star just kept on circling around it. That is why they also assumed that the Earth is the same age as the Sun, which also basically assumes that the Earth has always orbited the Sun, because they all were assumed to form as byproducts of the sun's formation, which obviously these assumptions were in place which disavowed any of this kind of calculation from ever occurring, because now that we figured that the Earth is 4.5 billion years old, so naturally to them their assumptions will completely destroy any rational thought concerning this matter. Because if if the Earth is 4.5 billion, it means the sun also has to be 4.5 billion, if not older. So what they did is they said, well, to hell with your Kelvin, Helmholtz nonsense. There has to be something else in the center powering the star. So naturally what happened was they found out that there's something called nuclear energy, and they took this new finagled concept of nuclear energy and they went crazy with it. They started placing it in the central regions of stars. Say, oh, well, the stars are nuclear reactors. They are all these fantastic nuclear events that shine for billions and billions of years, and they all do strange things like explode and become black holes. Well, that's for later. But what it really should have happened, okay? What really should have happened is this. It should have took the Kelvin-Helmholtz mechanism. Let me go ahead and erase all of this. Before the nuclear age happened, they should have took the Kelvin-Helmholtz mechanism and come to the rational, very common sense oriented conclusion that if the Kelvin-Helmholtz mechanism were to actually be applied to the full extent to which it could be applied, we would have come up with a more reasonable solution for both stellar evolution and that it would have drawn the reasonable conclusion, I already said that, to the fact that the star will eventually become what is called the planet. As the star contracts, cools, radiates all its energy away, as heat and light loses mass to CMEs, solar wind, solar flaring. Of course, that's for earlier stages. But as you continue on this graph, you'll see that the star continues collapsing upon itself. Mind you, the rate of energy production on the surface will diminish considerably. So you have the heat loss being high when the star is young. Now, the Kelvin-Helmholtz mechanism only has that happening for 30 million years. But they should have come to the more reasonable conclusion, said that the third time now, that when you have a thing contracting, it's not going to keep on losing heat at the same rate as the sun is now. So as it cools and dies, the age increases exponentially. So you have 30 million years, and a star is 60 million years, and 120 million years, and 240 million years, 480 million years, a billion-year-old star. We call those red dwarfs. And you have an evolved red dwarf, maybe 1.5 to 2 billion years, and you have a brown dwarf, which is maybe 3 billion years old. Before you know it, it becomes really, really, really old. And for a previous talk, I had the Earth as being in excess of 61 billion years old, because as the star also evolves, it forms the core inside of its interior. But to continue on the Kelvin-Helmholtz, that's what happens to the star. You know, it radiates the heat away, but also the rate of heat loss diminishes because the heat moves into the interior of the star, and it becomes more convective inside the interior as the heat is moving inwards towards the central regions of the star, and it begins core formation, I'd say around red dwarf stage right down here. And that's when it starts flaring a lot, and then it loses mass quickly, But then a lot of those molecules form, trapping the heat because they have a high specific heat capacity, and then the star continues aging a lot slower as it builds the core in its center. And the core in the center is called, the planet. And making this area of the graph bigger, if I stretch it out over here, what happens is that core stays put, and the outer atmosphere of the star dissipates, and before you know it, all you're left with is a rocky ball of matter which has moved through incredible amounts of time concerning its rate of mass loss. Now, I wish Mr. Lord Kelvin were here now so I could show him how much modern astronomers have really screwed the pooch. Because what happened was the modern astronomers, they sort of just dropped the ball. They say, well, stars, all stars shine, and if it's not shining, it's not a star. So we'll make a little cutoff right there. Because these are brown dwarfs. These are something completely different than stars. There's no way they could be connected to each other, regardless of if it's obvious to anybody that doesn't have an advanced education in astrophysics, because that's what prevents them from learning these things, obviously. But when you have that cutoff point right there, what they're essentially doing is they're saying, well, we have the stars as powered internally via the nuclear reactors. So the entire star's evolution is dependent upon how that nuclear reactor evolves inside the star. So if it's not shining, clearly there's no nuclear reactor there. There's no source of energy. But the fact is that there was never a nuclear reactor. The source of energy was always the fact that it was collapsing on itself. That's it. There was no core at all. And as it evolves, it forms the core and places all those materials that it collects from interstellar space in the center as a giant vacuum vapor deposition chamber, or physical vapor deposition chamber. And we can see these ancient dead stars wandering the galaxy. But in other words, Kelvin and Helmholtz were on the right track to the understanding that stellar evolution is planet formation itself, and the nuclear people of the 21st century have misplaced nuclear reactions as being inside of stars, but the truth is that those belong in galaxies. And those jets that we see from radio galaxies. That's where fusion is taking place. So you have like Hercules A with its big lobes of matter being injected on either side. That's where fusion reactors occur, not inside of stars. Stars are very boring constructs that are electrochemical, thermochemical, and are the source of all creation of life and every single naturally occurring molecular compound in the universe.